Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at factorials and permutations. So these are counting tools that will help us in probability. So let's start with this example. 8 people enter a race. How many ways can first, second, third, fourth, up to 8th be arranged? So if we look at first, who finishes the race first, there are 8 possible people because there are 8 people who entered the race. So after that first person finishes, there are 7 people who can finish second. And then after those 2 finish, there are 6 people left who could finish third, and so on. By the time you get to 8th place, there will only be one choice because the other 7 have finished. So what do we do with these numbers? Well, for each of these 8 choices, there are 7 choices here. So we're really saying 8 groups of 7 or 8 times 7. Similarly, for each of these 56 choices, there are 6 choices for third, so 56 times 6 choices in total. All we're doing here is timesing these numbers. So the total answer here is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. It took a long time to say, takes even longer to put in the calculator. So fortunately, we have a function that does that for us. 8 times 7 all the way down to 1, we write this as 8 factorial. So whenever you see this symbol factorial, it means you multiply all the natural numbers, so from 1 times 2 times 3, all the way up to n. So 30 factorial would be 1 times 2 times 3 times 4 times 5, all the way up to 30. 8 factorial means 1 times 2 times 3 all the way up to 8, and you can put that straight on your calculator and you get 40,320. That is the total number of arrangements. Now it may seem very high, but if we look at some arrangements, so let's call the names of the people A to H. So A, B, C, D, E, F, G, H is one arrangement. Then I can have another arrangement where only the B and the C are switched around. There are going to be heaps of these possible arrangements. So we should expect a very large number. All right, let's look at some more examples. So there are 30 people in a class. Top 20 students ranked in order. How many ways can this be done? So I'm going to use similar logic to what we used in the previous slide. So for the first student, there are 30 choices. After I pick the first student, there are 29 choices for the second, 28 for the third, and so on. I'm going to go all of the way down to 11 because 11 to 30 inclusive is 20 integers. Now you can see this would take ages to put on our calculator, and it would be impossible to do this if the numbers were very large. But we can use factorials. See, even though I only want to go from 30 down to 11, I'm going to include from 10 all the way to 1 and then divide by exactly that. So how exactly does that help? Surely adding more numbers into the calculation makes it more complicated. Well, if you see that these two are equal, hopefully you can see that the top number is now just 30 factorial, and we have a function, we have a button on our calculator that does that. The bottom is 10 factorial. So this is much easier to put in our calculator than this would be, and this will give us the final answer. But even this isn't enough for us lazy mathematicians. We want an even easier way to put it in our calculator. So you actually can put this in your calculator as 30, then you press the NPR button, and then you press 10. This is equal to 30p10. The P stands for permutations. So permutations also involve factorials, but that is used when you're not picking or you're not arranging all of the objects in the collection. See, here we were only arranging 20 out of the 30 objects, here the objects being the people in the class. So the formula for NPR is n factorial over n minus r factorial. And that's exactly the formula that we used here. Here n was 30, n is the total number of objects you have, and r is the number that you want to arrange. So that's how we got r here being 20. We got 30 minus 20 on the bottom. So if you put that on your calculator, it's about 7.3 times 10 to the 25. It is a very, very large number. All right, let's try this one here. 3,000 people entered a contest. How many ways can first, second, and third be allocated? So here, we're going to use the same idea. We are just picking 3 now from 3,000. So the answer would be 3,000 P3. But the problem is 3,000 factorial is too high to put in our calculator. It's too large a number for most calculators. So sometimes we will need to use this formula. Turns out this simplifies quite a lot. See, using the NPR formula here, we have n equals 3,000. That's the total number of objects you have. So this will be 3,000 factorial divided by n minus r. So r is 3 because we're only picking 3 in order. So it will be 3,000 minus 3, which is 2,997 factorial. So it turns out that this is just going to be 3,000 times 2,999 times 2,998. This is how many choices you have for first. After you pick first, how many choices you have for second, and then how many choices you have for third. So this is still an extremely large number. It's 26,973,006,000. That's how many ways you could find first, second, and third. So my phone has a 5-digit PIN. Calculate the probability of guessing correctly on the first try if A, digits cannot be repeated. So what we have here is a collection of 10 objects. Those objects are the digits from 0 to 9 inclusive, and we need to pick 5 of them. Now, permutations require that there are no repeats. You can't repeat. So for example, in the example about picking first, second, and third, we're assuming we use permutations when you can't come first and second and third. So digits cannot be repeated. This is a permutations question because you're picking 5 from this group of 10 and arranging them. So there are 10 choices of which you're picking 5. It will just be 10p5. So 10p5 is 30,240. So if you're just having one try, the probability of guessing it correctly is 1 over 30,240. So what about if the digits can be repeated? So if the digits can be repeated, this is not a permutations question. Permutation is only when you take some of the collection and arrange it. You can't have repeats for permutations, but we can still figure this out pretty easily. See, if you can repeat the digit, you can have a pin like 55555. You can repeat the number however many times you want. So in this case, there are going to be 10 options for the first digit, 10 options for the second digit, and so on, 10 options for the fifth digit. So the total number of ways this can be done is simply 10 to the power of 5. And again, if you're only picking one time, if you're only having one guess, the probability you're successful here is 1 over 10 to the power of 5. All right, let's now look at this question. Suppose I have a class of 30 and randomly assign a prize to first, second, and third. Calculate the probability that Daniel and Erica each win one of the prizes. Of course, their names here, Daniel and Erica, don't mean anything. Essentially, we're just asking what's the probability that 2 specific students win a prize. So let's use our counting tools. Let's use our permutations. So if I'm picking 3 students to win a prize, the total number of ways this can be done is 30p3. So now I just need to figure out how many of these permutations will involve these specific students. So here are the possibilities. I could have Daniel come first, Erica come second, and some other random student come next, or I could switch them around, Erica then Daniel, or I could have Daniel, another student, then Erica, and so on. It turns out there are 6 ways that I can arrange Daniel and Erica, or 3p2. Here we're looking at the place. that they can come. They can come first, second, or third. So for each of these 6 options, there are 28 possibilities to go in the box. So the total number of permutations involving Daniel and Erica is 28 plus 28 plus 28 and so on. Quick way to do that is obviously 28 times 6. So putting that on our calculator, we get a very low probability of about 0.007. It does make sense. It'd be very unlikely that both of them win a prize given how many permutations there are. So just one quick note, permutations that we've used in this video, they are when the objects you're arranging are ordered, where order matters. So something like first, second, and third, it does matter. You coming first is different to you coming second. But in a subsequent video, we're going to look at combinations where the order doesn't matter. So it's really important you make sure when you're doing these questions, you understand whether or not the order of the arrangement matters. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.